Hello and welcome to another Year 10 Chemistry video. This video is about the 2019 Double Award Hired Year paper. Question number 1. The table below gives some information about the elements. First of all, we need to fill in the gaps. So for chlorine, the electronic structure is 2,8,7. Now we can work that out in two ways. First of all, we know that the last number's got to be a 7 because of the group. And it's got to have 3 shells because of the period. If you're unsure on doing it from the group and period, however, you can look at your periodic table and you can see that chlorine will have 17 electrons. So therefore, we can draw the electronic structure for 17 electrons and work out that it will be 2,8,7. The next one was phosphorus. We worked this out by simply adding up those 3 numbers. And then our last one, potassium, is going to be in period 4 because there's 4 shells. State one observation you would make when potassium reacts with water. Well, we're going to get a lilac flame. Apart from using wearing gloves and wear safety goggles, give one precaution that could be taken when adding potassium to water. We could use a safety screen. We could also handle with tongs in case there's any moisture on our hands that it may react with. The next one was give the formula of solution A. Now, if you look back, solution A is from potassium with water, so it's going to be potassium hydroxide. Remember, to find the formula, we need to go and do top swap drop, and I can see that potassium is K plus and hydroxide is OH minus. Suggest a value for the pH of solution A. Well, they're called the alkali metals, so they're going to have a high pH. Remember, the strongest alkali is around 14, so 13 or 14 is what we're looking for there. And then name a group 1 metal that is more reactive than potassium. Well, remember, as we go down group 1, it becomes more reactive. So that tells me there that anything below potassium, so we could pick rubidium, cesium or francium because they're below potassium. The Earth's early atmosphere around 4,000 million years ago contained mainly carbon dioxide and water vapour produced by volcanoes. Explain why the large percentage of water vapour in the Earth's atmosphere decreased over geological time. The Earth cooled or the temperature decreased and the water vapour condensed to form oceans. Give 2 reasons why the percentage of carbon dioxide in the Earth's atmosphere has decreased over time. The first one is that it's been absorbed by plants as they carry out photosynthesis, and the second one is that it's been absorbed by rocks or oceans. During the last 250 years, the percentage of carbon dioxide in the Earth's atmosphere has increased from 0.03 to 0.04, and this has led to global warming. Give 1 reason for this increase and explain why global warming is a cause for concern. So first of all, the reason why we've got more carbon dioxide, the big one is the combustion of fossil fuels has released carbon dioxide into the atmosphere. You could also have said at this point deforestation. And then our second part is, why is it a concern? Well, global warming is an issue because it is leading to climate change and rising sea levels. And then for our balance in there, I've shown you my workings. We're looking for a 4 and a 2. So there's my workings to help you work that out. Some Year 10 students were given 3 unknown white solids, A, B and C. They carried out a series of flame tests and silver nitrate tests to identify the solids. Their results are shown in the table. So A, apple green flame, barium, and a cream precipitate, so barium bromide. Lithium is a red flame, chloride is a white precipitate, so I get lithium chloride. And sodium is a yellow flame, and iodine is a yellow precipitate, so I get sodium iodide. We then need to complete and balance the symbol equation for the reaction between magnesium chloride and silver nitrate. What I want you to think, guys, is when we do these, you swap over the metals. So we end up with silver and chlorine together and magnesium and nitrate together. We balance it, the 2 there comes from, and the way we can remember that it's AgCl is if I look at the back, for silver chloride is Ag plus and Cl minus. 0.103 grams of silver nitrate, AgNO3, was used to make up a solution. calculate the number of moles of silver nitrate in this mass and give your answer in standard form. So remember, there's our equation triangle. Normally I have it mass over Mr. Moles. The letter N is the moles. So I've got the MR numbers. So I'm going to calculate the MR using the MR table. I then do mass over moles. Mass over MR. So I'm going to do 0.103 divided by 170. And what we can do is to put it in standard form. If it doesn't do it in our calculator, if you hit Scooby-Doo, it will turn it into standard form for you, and you get 6.06 times 10 to the minus 4. A student investigates the solubility of ammonium chloride by adding different masses to 10 grams of water. He uses the apparatus shown. 10 grams of water is placed in a boiling tube and 3 grams of ammonium chloride is added. The tube is heated until all the solid dissolves. The tube is allowed to cool. The temperature at which solid ammonium chloride first appears is recorded. And we then repeat the experiment using different masses of ammonium chloride, and the results are shown in the table. What practical problem is the student likely to come across in finding the first two results? Now these are at 4 and 10. Suggests how this problem might be overcome. Problem that we've got is 4 degrees and 10 degrees are colder than room temperature. Room temperature is generally around 20. So that's our first problem. Suggestion of how we can overcome this. They can overcome this by placing the boiling tube in ice. We've then got a graph, and that's the data from the previous page. Just again, I'm going to stress it. We're going up, it's a nice graph here because we're going up in tens, which means every small square is 1, and we're going up in ones, so every small square is 0.1. Look at my line of best fit. It's smooth, it's not shaded. The student is given a boiling tube containing 5 grams of ammonium chloride in 10 grams of water. He stirs the ammonium chloride in water and heats it to a temperature of 45. State whether all the ammonium chloride dissolves and give a reason for your answer. So I've gone to 45. I've gone across the corridor and down the stairs. And I can see from the graph at 45 degrees, only 4.9 grams will dissolve. So there'll be 0.1 gram left over. The student is asked to use a different method to find the exact solubility of another compound in water at room temperature. He knows that it has a value of approximately 7 grams per 100 grams of water at this temperature. He's given a 5 gram sample of the compound and a common laboratory equipment but no heating apparatus. Describe how he would carry out his method and how we would find the solubility. So, first thing that he's going to do is he can't use 100 grams because he's only got 5 grams and it will take 7 grams per 100. So all of that will dissolve and it won't be maximum solubility. So he's going to do half of that. Instead of measuring 100 grams, we're going to measure 50 grams of water at room temperature and we're going to dissolve as much of that 5 grams as we can. That's the first thing. We're then going to filter any of the salt which is at the bottom and then we're going to dry it and weigh it. We're then going to work out by how much is left over. So let's say that 5 grams we tried to dissolve and we were left with 1.5 left over. So that tells me that 3.5 grams have dissolved in 50 grams of water. So to work out in 100 grams, I'm going to double it, which means I'll get 7 grams dissolved in 100 grams of water because I've got twice as much water, so I'm going to double it. And that's in my answer by there. A bottle F contains a mixture of liquids E and F. Liquid E has a boiling point of 57 degrees and liquid F has a boiling point of 95 degrees. Describe the process of distillation and explain why it can be used to separate these liquids. So the first thing, remember, in distillation we're going to heat to the lowest temperature. So I'm going to heat to 57. So heat the liquid mixture until the liquid E boils. You then go in to condense that vapour and collect it in a different container. So I've now described the process of distillation. Last thing, we need to explain why it can be used to separate these liquids. These liquids can be separated by distillation as they have different boiling points. and liquid F will be left in the original flask as it has a higher boiling point. One molecule of liquid E contains 2 oxygen atoms. The percentage by mass of oxygen in liquid E is 43.2%. Use the following equation to calculate the relative molecular mass MR of liquid E. I'm going to do that using this equation. So first thing that we're going to do is each molecule contains 2 oxygen atoms, and 2 times 16 is 32. So I'm going to put 32 on top of that equation. I don't know the MR, but I do know the answer is 43.2. Now to rearrange this, I'm going to swap the question mark and the 43.2 around, and I'm going to do 32 divided by 43.2 times 100 to give me 74.1. Explain how the processes of boiling and adding washing soda remove hardness from water. Include equations in your answer. So first thing that we've got is boiling removes temporary hardness. And remember, we have to remember here that hydrogen carbonate ions are responsible for temporary hardness, and they are not thermally stable and are decomposed easily on heating. And there's my equation. So we've got calcium hydrogen carbonate gives calcium carbonate plus water plus carbon dioxide. And it produces calcium carbonate, which is leading to the buildup of limescale. Now, remember, temporary hardness is hydrogen carbonate. So the next bit, we're going to look at permanent hardness, and that's sulfates. So washing soda is required to remove permanent hardness, and washing soda is sodium carbonate. When washing soda reacts with calcium sulfate or magnesium sulfate, it forms a carbonate, and there's our equation. So remember what we saw earlier in this paper. When we're trying to form equations, we can simply swap the metals around. So look, rather than having calcium sulfate, we've got calcium carbonate, and instead of sodium carbonate, we've got sodium sulfate. Big things to remember here: the temporary hardness is hydrogen carbonate, and permanent hardness contains calcium sulfate. But all types of hard water contain calcium or magnesium. Chlorine is a non-metal found in group 7 of the periodic table. When it is bubbled into a solution of potassium iodide, there is a colour change from pale green to brown. Explain why this reaction occurs. Now remember, chlorine is more reactive than iodide, so it wants to steal that potassium. So first mark, chlorine is more reactive than iodine. Now the more scientific, the excellent answer here is not to say it steals the potassium, it's to say that it displaces the iodide. We've then got a balanced symbol equation for the reaction between chlorine and potassium iodide. Now, the thing we've got to remember, chlorine doesn't like being lonely, so it's Cl2. I go to the back of the paper then to find potassium iodide, and I work that out by top swap drop, K plus and I minus. And I know that the non-metals are simply going to swap, or the metal's going to swap. So look, this time, rather than the K being with the I, it's swapped and it's with the Cl. And I know that it's got to be KCl from looking at the back. And then finally, we've got I2 is just like chlorine, iodine doesn't like being lonely. The symbol equation for the reaction between iron and chlorine is as follows. Calculate the mass of chlorine needed to react with 1.32 grams of iron. So the first thing that we've got here is I know that my mass of iron is 1.32. So I'm going to write that down below the Fe, okay? And I don't know the mass of chlorine. They want me to find that, and I can ignore for now the FeCl3. So I know the mass of Fe, so that's my known. I don't know the mass of chlorine. So I know I've got to do a reactant mass equation. So it's known mass over known MR times unknown MR. My known mass is 1.32. My known MR, I've got 2 iron, so I'm going to do 2 times 56. And the MR are below my little box there. And then I've got 6 chlorines in total. So I'm then going to do 6 times 35.5 to give me 213. And then it's a case of me plugging in these values from my checklist into my equation. So known mass, 1.32. Known MR, 112. Unknown MR, 213. And it gives me an answer of 2.51 grams. Balance the symbol equation of this reaction. I've shown you my workings. It's a 3 and a 2. A chemist calculated that if she reacted 7 grams of chlorine with an excess of bromine, the theoretical mass of chlorine tribromide produced is 27.55. However, when she carried out the experiment using 7 grams of chlorine, the mass of chlorine obtained was 21.34 grams. Calculate the percentage yield of chlorine tribromide. So I'm going to do my actual divided by my theoretical times 100. So I do 21.34 divided by 27.55 times 100 to give me 77.5. Hydrogen peroxide solution is used in commercial stain removers. A GCSE class investigated how effective 4 stain removers are at removing stains. Stain removers A, B, C and D contain different concentrations of hydrogen peroxide. The students tested how effective each one is removing an identical oil stain from 4 towels. Their findings are outlined below. So I've got 4 different stain removers. They've all got different working temperatures. We've got different costs, different times, and then different volumes required. The first one, in carrying out this investigation, which variables were kept the same in order to get valid results? Now, first thing I'm going to spot then is they all were at different temperatures. They were all at different volumes. So I can't have kept any of those the same. So if we go through, I can't choose the first one because it says the same volume. I can't choose the second one because it says the same temperature. And the other thing that differs is they've also got different costs. So I can't use that one. So the only one remaining is the third one. Tick all of the statements which could explain why stain remover A has to be heated to 50 degrees before it removes the stain. It's not because it's cheap. It's not because it's heat resistant. They told us it's a different concentration, so it's low. And it also takes a long time. So we're heating it up, because remember, a higher rate happens when we have a higher temperature. The student found that stain removers B and D used the same volume and worked best at the same temperature. Assuming that they have the same hydrogen peroxide concentration suggests a possible reason why stain remover D removes it more quickly than stain remover B. Remember, we're talking about washing powders here, so stain remover D may contain enzymes. Think of your biology lessons. Enzymes are biological catalysts. They speed things up. Now, what I want everyone to do is you're going to have to flick back and forth from this page. So I'm going to read the page to you, and then I'm going to go over for my answers. So one student went on to investigate the decomposition of hydrogen peroxide. The equation is shown. The student investigated the effect of changing concentration on the hydrogen peroxide solution on the rate of reaction, and she uses manganese dioxide as a catalyst in each experiment. This is the method. Pour 50 centimeters cubed solution of concentration R into a conical flask. Add 1 gram of catalyst and place some cotton wool loosely in the neck of the flask. Record the balance reading and immediately start a stopwatch. Record the balance reading every minute until the mass no longer changes. Carry out the experiment twice more using peroxide of different concentrations R, S and T. Her results are plotted on the grid below. Now, we can see that R and S, and T are all at different rates because some lines are steeper than others. T is the fastest because it's the steepest. R and S, out of R is the slowest and S is in the middle. R and S, we've used exactly the same amount because it's ended in the same place. And I just want you to notice my workings, everybody, at this point now for the gradient, and they've drawn the tangent for me. Using the tangent on the graph, calculate the rate of reaction for concentration T at 2 minutes. So from my graph, remember, it's the change in Y divided by the change in X. So I've got my values there. So my change in Y, Y2 take away Y1, is done by those values. And my change in X is done by taking away those values. And I end up with minus 0.04. But actually the minus isn't required because we're looking for rate. So it can simply be 0.014. The initial rate for concentration S is half the rate for concentration T. Explain this difference in terms of particle theory. So, if it's half, it is slower. So what we need to remember then is the slower rate happens with a lower concentration. So if it's half the rate, that tells me for my first mark that the concentration of S is half that of T. That means that I've got half the number of particles present in the same volume, which means half the number of successful collisions occur. So those are your 3 marks. That's the end of this revision video. If you've got any questions on that, please come and bring it to one of your science teachers and they can help you with it. Other than that, good luck with the rest of your revision.